I hope you did not have any troubles with lesson 8. If you did, please again email me so I can help you. Today we're going to talk about what happens when we change our frequency and how changing the frequency changes the period. The other thing I do want to do from the beginning is also talk about the calculator, how you can match your work to your graphing calculator and how it would definitely help you. Let's just go back to the very beginning, to the basic that we need to know. If we had y is equal to a, and this could be sine or cosine, sine and cosine are called sinusoidal. It's one or the other, and that's just the overall name. And so then which sinusoidal function are you talking about? Well, then your sine or your cosine. And then we have bx. We don't really do the phase shift, the c, so I'm not going to write it in, plus d. So this again, amplitude, and works the same as our vertical stretch. This is the frequency. And again, it's what you literally see from 0 to 2 pi. This is going to be the midline shift. And for right now, our midline is all 0. We are not shifting up or down. It's the same as a vertical shift up or down. We're not going to be shifting, but it's there. And most important, the period is equal to 2 pi divided by the absolute value of the frequency. Because, you know, you could have negatives. We're not going to use negatives. The formal definition has this absolute value in it, so we're going to keep the absolute value. But I'm going to give you nothing but positives for B, just so you don't get concerned. Now, let's start with a nice basic y equals sine of 2x. Now here's where I'm going to ask you to please have out that chart of all the angles that I asked you to copy yesterday, because I don't have the room on this tiny whiteboard to keep writing those things down. So you're going to need them. I'm going to be referring to them, and if you don't want to get lost, you should have that out. So if I'm going to go through this, my amplitude is 1. There's nothing there that I can see. There's that invisible 1. My frequency is 2. This means I will see 2 full sine curves from 0 to 2 pi. Well, it's the first time we're going to see more than one curve. Now I need to know the period. What's the distance on the x-axis I'm going to need to show just one of the curves? So the period is 2 pi over now the frequency of 2, so that gives me pi. What this is saying, that between 0 and pi, I'm going to see a full curve. That is what this means. From 0 to pi, I will have one full sine curve. So let's take a look at a graph. Now you have a graph on your paper. I'm going to have to get caught up to you. So here's my y and my x, and I am going to make my amplitude up to 3. So maybe I can use this graph again like yesterday. And then 30, 60, 90. Okay. Now when I look at this, here's how I'm going to tie everything together. I'm going to see a full rotation by pi. Here's the pi. So this is like an imaginary invisible line, but I'm drawing it here because I want you to see. A full sine curve is happening from here to here, and then at 2 pi, here's my other invisible barrier. This is where I'm going to see my other full sine curve happening. Now, if I know how my sine function works, I'm going to have a much easier time. How my sine function works is this. I begin and I end at 0, and the middle is 0. So just like the pattern on that table, just like the y's going around the unit circle. 0 is 0, sine of 90, sine of pi is normally 0, but now what I'm doing is I'm shrinking. I took the 2 pi and I shrank it. This is now a horizontal shrink by 1/2. I am using, instead of the full graph, half the graph. So where I normally would have hit 0 at pi, I'm now hitting it at 90. And where I would have hit 0 at 2 pi, half of 2 pi is pi. So I shrank it. I pushed it over. That means the same thing's going to happen between pi and 2 pi. I'm going to begin at 0, I'm going to end at 0, and the middle now is 0. Same thing. I shrank it. I pushed it in. The next thing is, in between my 2 zeros was where I hit my highest amplitude if I was positive. So here's my 1 up high. And then between these 2 zeros was where I hit my lowest, and here's my down low. And same thing here. Here's my up high at 1, and here's my down low. And here is one full sine curve happening between 0 and pi, and here's my other. So now between 0 and 2 pi, I have 2 full curves. My period is pi. So see if that feels comfortable to you. Let's take a look at exercise 2 on this one, 2 cosine of 4x. So this is now 2 cosine of 4x, and I'm going to get rid of all of this, and we're going to see what happens. So these are the things that so if I put my graph back together. There we go. All right, now we can read that again. Okay, let's start with this guy now. Again, 2 cosine of 4x. So my amplitude, my height is now 2. My frequency is 4. I am going to see 4 full sine curves, cosine curves between 0 and 2 pi. And my period is going to be pi over 2, 90 degrees. I am going to see a full curve by 90 degrees. That means I shrank my graph from the 4 quadrants basically down to 1 quadrant on the graph, 90 degrees. Then in this 90 degrees, I am going to see another cosine curve. In this 90 degrees, I'm going to see another cosine curve. And in this 90 degrees, I'm going to see my last cosine curve. I'm going to see 4 full cosine curves. Let me move this one over so a little. Yeah, there it goes. That's a little bit neater. So, cosine. Cosine starts high and ends high. The vertical stretch is 2. The amplitude is 2. That means cosine starts at 2 and ends at 2. Halfway in between these, it's down at -2. Notice I'm just working out how it goes based upon those quadrantal angles from the unit circle. Halfway in between these 2 points, I'm at 0, and halfway in between these 2 points, I'm at 0. So here's my first cosine curve. It's really narrow, but that's because I shrank my space from here to here. It's 1/4 the size. That's what we would have said back in the first marking period. So if I follow the pattern, begin high, end high, halfway, I'm down low. Begin high, end high, halfway, I'm down low. Begin high, end high, halfway, I'm down low. And in between that are my zeros. And you try to make a nice fluid. And there you have the graph of 2 cosine of 4x. So you should try, while I'm erasing this, you should maybe stop the video, try to do the third one, 3 sine of 1/2 x. See what you can do. I mean, use a pencil, erase it if you're wrong, but give it a shot. All right, so now I'm starting 3 sine of 1/2 x. So if y is equal to 3 sine of 1/2 x, here's my amplitude of 3. My frequency is 1/2. Now this 1/2 means a horizontal stretch. I am taking twice the size of the x-axis. And let's see that with the period. The period is 2 pi divided by 1/2. Well, 2 pi divided by 1/2 means multiply by the reciprocal, and that gives me 4 pi. Like if I wanted to see this full sine curve, I would have to have 2 full rotations on my x-axis. I would have to go out to 4 pi, which we'll do eventually. We're just not doing it yet. So, because I want to get you guys all comfortable with the work. So right now, I'm only going up to 2 pi. So if I'm only going up to 2 pi, then I am physically going to only see half my curve. And sine begins at 0. It ends at 0, but I'm not going to see the end. The halfway point on sine is back at 0. So now I just stretched this. The 0 that would have been here just got stretched because my horizontal stretch by scale factor of 2. In between the beginning and the middle, since this is 3, my 1 times 3, my vertical stretch of 3, here is half that curve. And if I wanted to see this full curve, I would have to extend this all the way out to 4 pi. I don't have the room where I would do that. So that was a little tricky. So I'm going to ask you to try to do the next couple of graphs yourself without me on the homework. But the next thing I want to talk to you about now is the calculator. And let's talk about how we would use the calculator. First and foremost, we're using radians. So we have to go to mode, and now we have to be in radian. You got to make sure you're in the mode and you turn it into radians. Once you turn on radians, you hit enter, turn it on, quit out of there. Now we have to go to the window. See, our window now is completely changed. What I've been using now is 0 for x minimum, and I'm using 2 pi, so second and the pi key, and I've been scaling my graph. You can now write down, how are you scaling? Are you scaling by 30 degrees, 45 degrees? What are you doing? I've been using 30-degree increments because it makes my graph nice and neat. So that's what I'm going to put down, 30 degrees. But 30 degrees, if you recall, is pi divided by 6. And my y, like what's my y doing? Well, it depends upon my amplitude. Let me put in the y minimum of -5, and let's go to a y maximum of 5, just so we can have enough space to see. And let's go to y equal, clear out anything that's there. So now if there's nothing in y equal, just hit graph. And look, you have the exact same graph that's been on the packets. All right, now if we want to just test this one, let's go back to y, and now let's write in 3 sine, and now let's put in the 1 divided by 2x, close the parenthesis, let's hit graph, and look at that, we're getting the exact same graph we just made. You can check every single graph and see if you're doing it right. It's always helpful, because if you now look at the next question, I'm asking you to graph 3 cosine of x. So I didn't give you a frequency on this one. No, actually, I gave you on the next one 3 cosine of x. And you can see that it went from -2 pi to +2 pi. And the next thing they want you to do is sketch 3 cosine of 2x. So I'm not going to sketch the 3 cosine of x. I'm going to go straight to the 3 cosine of 2x, but I have to fix my domain. On this picture, the domain is going out to -2 pi. So let's fix the domain in the window. We are now -2 second pi to 2 pi. And let's now type in this next problem, which is 3 cosine of 2x. So type that in, 3 cosine of 2x. And hit graph. And look at what's happening. The amplitude is still 3, but the frequency went from 1 to 2, and then that meant that between 0 and pi, you will see a full curve. But that would be if I only was starting at the y-axis where we were 0. We're not anymore. We're going negative as well as positive. So we have our 90, our 180, our 270, our 2 pi. But now we also have our negative 90, our negative pi, our negative 270, and our negative 2 pi. Our amplitude is 3. So we definitely need to have that. And let's follow along with what's happening. Between 0 and pi, and again, I'll use a lighter color, between 0 and pi, we are going to have a full curve, and between pi and 2 pi, a full cosine. The same then is going to happen between 0 and negative pi, and between negative pi and negative 2 pi. Since I'm now going out to the negative, I'm going to have 2 full cycles on the positive side and 2 full cycles on the negative side. Cosine again starts high, ends high. Halfway in between, it's down low, so here are my zeros. Start high, end high, halfway in between are my zeros. Start high, end high, halfway. Oh, that's pretty bad graph, bad drawing for me, sorry about that. And then start high, end high, halfway, down low, and then there are my zeros. So now I'm going to try to make nice smooth curves. This takes a little bit of practice. You can't make points. Don't give me pointy things. That would be like absolute value. And even though it's hard, try to make those lips. I know that is hard, just to give it your best shot. And so now you would have 4 full cycles between negative 2 pi and 2 pi. That would now be your domain. Your amplitude was still 3. And period was pi. Between 0 and pi, we saw 1 full curve. So you'll get used to reading these. I really do believe you will. And if we just take a look at the next one, it now changed it to 3 cosine of 1/2 x. So this next one says y equals 3 cosine of 1/2 x. Well, this same amplitude, but now the frequency is 1/2. So again, for the period, you're dividing 2 pi by 1/2, and that actually gives you 4 pi. Now look at, I literally have 4 pi on this graph now. It's just that to do this right, I'm going to start on the positive side. On the positive side, I am going to see only half of my graph between 0 and 2 pi. That's what this means. So between 0 and 2 pi, I'm not going to see a full graph. Between 0 and 2 pi, I'm going to see a half a graph. So whereas I would have started high and ended high with a b of 1, not going to be blue now, halfway would be 0. Would be my down low rather. So now my down low is here. And in between 0 and 2 pi, a pi is where I hit 0. So this is the first part of my cosine curve. Start high, halfway down low, and in between I'm at 0. I'm missing the other half. But they want me to go negative. So here, I started high, and halfway, I would be down low. And in the middle, I would be at 0. And here would be... So this looks like an upside down cosine curve, even though it's actually positive, because here's the positive. But it does look like I did a -3 if I were starting at 0 from the beginning. So that was pretty cool. So you definitely want to try these. So these are the graphs. Take your time, and I'm going to have you do the graphs on the packet. But now what I really want to talk to you about is the period, how the frequency and the period really do go together. And I want to do exercise 2 and 3 with you because that, I think if I do these with you on the homework, you'll be better. And you can always, check all your graphs on your graphing calculator and look at the domain. If the domain is only positive, start your x minimum at 0. And if your domain is negative and positive, then start your domain at -2 pi. So just always tailor each graph to what they want so that you can see if it's right on your paper. All right, let's again talk about period. The period is the distance, the distance on the x-axis for one full cycle of the function. Period comes from 2 pi divided by the frequency. So if the frequency is 1, between 0 and 2 pi, you're going to have one full cycle. But the frequency isn't always going to be 1. And here's another one. The frequency is not always going to be in nice numbers. Sometimes the frequency is going to be given to you in terms of a radian angle. So we're going to have to take a look at that. Let's take a look at exercise 2. Exercise 2, letter A, we have y equals 3 cosine of x. Well, the invisible 1 here tells me my frequency is 1 and my period is 2 pi over 1, so it's 2 pi. Nice and straightforward. Then we get to letter B where it says y equals 3 cosine of 2x. Well, now my frequency is 2. So my period is 2 pi over 2, which gives me pi. So now between 0 and pi, I would see one full cosine curve. If we look at C, where y is equal to 3 cosine of 1/2 x, then my frequency is 1/2, and my period now is 2 pi divided by 1/2, and again, 2 pi divided by 1/2 means multiply by the reciprocal, 2 over 1, and this gives me 4 pi for my period. So you got to be really careful when they're giving you fractions. Exercise 3 has them all jumbled up a little bit. Let's take a look at exercise 3. So exercise 3 has y is equal to 6 sine of 4x. My frequency is 4, and my period now is 2 pi divided by 4, so this gives me pi halves. By 90 degrees, I'm going to see a full sine curve. B is 8 cosine of pi over 3x. 8 cosine of pi over 3x. Well, don't get concerned. Same work. The frequency now is pi over 3. And the period would be 2 pi over pi, 2 pi over pi over 3. You have to take your time with the math. This would be 2 pi times the reciprocal, 3 over pi. Pi's are going to cancel. This is going to give you a period of 6. Now look at the difference. When your frequency was a whole number, or some kind of rational number, I should say rational number, your period is in radians. When your frequency is in radians, your period is in rational numbers. We're going to use these problems like this when we do real life trig functions. So know that that's coming down the line. We're going to talk about the tide, high tide and low tide. That's a sinusoidal function. That can be expressed in sine or cosine. We're going to talk about a couple of different things. And in the real world, you would be having your x-axis in terms of rational numbers. So if your frequency is in radians, your period is rational. If your frequency is rational, your period is in radians. Let's take a look at C. C says negative 12 sine of 2/3 x. Well, my frequency is rational, it's 2/3. So now I know that my period is going to be in radians because I have 2 pi divided by 2/3, which again, 2 pi times the reciprocal, 3/2, this is going to give me 3 pi for my period. So rational frequency, radian, period. Radians for my frequency, rational for my period. Very important. And if we look now at exercise 4, they want us to graph 2 sine of 4x, and they're giving us both a negative and a positive graph. So we are going to need to make sure that we're using negative to positive. Your calculator, because where we left off with the graph was going from negative 2 pi to 2 pi as the domain. So a good thing to always do for yourself is to put it on the calculator and make sure that you can get the same thing on your paper. That would definitely help you. So if I take number 4, which says 2 sine of 4x, and I graph this, I'm seeing a ton of sine curves. It's like up and down, up and down, up and down. It almost looks like, you know, your heartbeat. Well, let's take a look at why we saw so many. So when we had y is equal to 2 sine of 4x, my amplitude was 2, my frequency is 4, and my period is 2 pi over 4, which is pi halves. So by 90 degrees, I have a full sine, which means I'm going to see 4 full sine curves. Because if here's 90, there's a full curve. Here's 180, a full curve. 270, a full curve. 2 pi, full curve. And then at negative 90, full curve. Negative 180, full curve. Negative 270, full curve. Negative 2 pi, full curve. That means I'm going to be drawing 8 curves. My picture is going to look like my calculator. My amplitude is 2, so I might stretch this out so that I can maybe draw it a little bit easier. And sine, again, if I think about everything with sine, sine starts at 0, ends at 0, middle is 0. There are my 3 zeros. My amplitude is 2. Oh, maybe I made it a little bit too strong. Yeah, it's going to be pretty narrow. And then I start at 0, end at 0, middle is 0, halfway I'm up high, and halfway I'm down low. Start, end, middle, high, low. Start, end, middle, high, and low. So this, if I start here, it goes like this. Wow. And that was only the positive side. So let's do the same thing. Middle, middle, middle. This one now, like, notice I'm going down because I'm on the opposite side, and here I'm going up. Middle, middle, midline, and then here I'm down, and then here I'm up. Down, up. Down, and up. So if I continue, I went down, up. Yikes. Boom, there we go. Now I look just like my calculator looked. So give that one a try. And the last classwork problem we're going to talk about is this real life problem, our first taste of a real life problem. We're not graphing it, we're just going to talk about it. This final problem says the heights of tides can be described using a sinusoidal model in the form of y equals a cosine bx plus c. So let's start with that, number 5. Y is equal to A cosine of bx plus c. So they gave me capitals. I don't know why. If high tides are separated by 24 hours, so your high tide is separated by 24 hours. So that means the period of time it takes for high tide to high tide is 24 hours. Well, we got to find the B, because that's what they want. They want the frequency. Well, if I take period, which is 2 pi over B, and I know that this equals 24 hours, I can put this 24 over 1 and I can make a proportion. Cross product. 2 pi is equal to 24b. I can divide by 24. And I can reduce. 2 over 24 is 1 pi over 12. My frequency is 1 pi over 12, choice 3. So when my period is rational, my frequency is in radians. And if my frequency is in radians, my period will be rational. So I hope this helps. Good luck.